Now we're going to prove that the integral of x dx between 0 and 1 is 1/2. But we are not going to use anything other than Riemann's sum. Okay? So a quick idea is that we can graph the function. It's easy to graph. We know that this is the y is x. So this is the an easy function, x-axis. This is the y-axis, okay? So when we can use the Riemann sum, we want to make sure that we have two things. That we can approximate the function by rectangles, and that one of them is trying to come up to approach the area from above, one from down or below. And once they do, they will have to get to be equal when we get to infinity. Okay, we're gonna see what we mean by that. But first, we're gonna see what we can do. First, let's see what we can get. Assume that this is 1. Okay, so what's this one is saying? So it's saying that the integral of between 0 and 1 of x is 1/2. We can use geometry to see that the area here, this is a triangle, so it's having base 1 and height 1. Therefore, the area is 1 times 1/2, which is 1/2. Okay. For Riemann sum, we use subdivisions using sample points. X sub k is a plus k b minus a over n. Okay. In our case here, so this we start from 0 and we get until the last one. So here x k is gonna be a is 0 and b is 1. So xk is gonna be k over n. So when x is 0, we get 0. That means we start from here. When k is n, we get 1. That means we are here. So these two are very important. This is x sub 0 and this is x sub n. Okay. The other subdivisions are located inside. Okay. Let's focus on one here, x sub k and x sub k plus 1. So this difference here is what we call delta x. Delta x is the difference between xk plus 1 minus xk, and using the formula here, so it's going to be k plus 1 over n minus k over n, which is 1 over n. Very important, okay? Now, we approximate the area by the lower rectangles, okay, and the upper rectangles. So we make error, but we are trying when we get to approximate, we're trying to make this error less. So this is the error that we are making by using the upper rectangles, and this is the error that we are making by using lower rectangles. So when we try to get n to infinity, we're trying to make this error as small as we can. Okay, so now let's use our definition, but we're going to use the lower letter s for the sums of the rectangles, the small one, this one in red, and big S for the sum of the rectangles, the green one. Okay, so here we know that this is just the limit as n goes to infinity of delta x times f of xk. Okay, but we need to sum up, because this is just for one rectangle. We will see where k is gonna go. Okay, here we're gonna use the same thing, the limit as n goes to infinity, delta x, the sum of f of xk. Here, to use these lower rectangles, we're gonna go from 0 to n minus 1. So it's this one in red. To use the upper one, the big S, we're gonna go from 1 to n. And both of these integrals, they are equal to this integral of f of x, which is x. It means 0, 1, x dx. So these two. So First, let's compute s, the small one. So it's the limit as n goes to infinity. Delta x, we computed that, it's 1 over n. The sum k from 0 to n, f of xk. That means f of k over n, because that's x. So k over n. Okay? So here we can rewrite this one as the limit as n goes to infinity of k over n squared with the sum going from 0 to n. We can do it one more time. The limit as n goes to infinity of 1 over n squared. What's the sum? The sum of k from 0 to n. N minus 1. Sorry, n minus 1. So we know this one. We know this sum here. So it's going to be the limit as n goes to infinity of 1 over n squared. This sum is going to be n minus 1 times n over 2. Okay, now we know this one here. What's this limit here? It's 1/2. Okay, treat this n and n minus 1 as a function which has order x squared over x squared, which is 1. With this half, it's going to be 1/2. Okay, next let's compute this is the small s. So the small s is 1/2. That means the area of the sum of the small rectangles. Now big S is the limit of delta x sum of k going from 1 to n of f of xk. So as n goes to infinity, so 1 over n, and again f of xk is 1 k over n, so it's going to be the sum of k over n. K going from 1 to n. But we take the n outside, it's going to be the limit of 1 over n squared, the sum of k going from 1 to n. But we know this, okay? So it's going to be the limit as n goes to infinity of 1 over n squared times n plus 1 over 2. Okay, what's this one here? 1/2, that's the limit. Okay, so we have the big S equal to the small s equals to when n gets bigger. That means our integral between 0 and 1. So this means that the integral between 0 and 1 of x dx using Riemann sum is 1/2. Okay, so therefore we proved that the area or the Riemann sum of x dx between 0 and 1 is 1/2. Okay, I think that's all we needed to do. Thank you very much.